In this video, I'm going to show you how to calculate a standard deviation from confidence intervals. And to give you a bit of background on this issue is that I all too often come across a figure in a paper where they'll show the bar chart with confidence intervals, but they don't actually report any of the descriptive statistics associated with the figure. So here's an example of a good bar chart with confidence intervals. But if you look in the paper, at least from what I can tell, you won't find the actual standard deviations anywhere. You won't even find the means reported anywhere. So you're having to guesstimate, looking at the chart, exactly what these values are. And one of the reasons why you might want some level of precision is that you might want to calculate an effect size estimate associated with this chart if the paper didn't do so. And one of the reasons you might want to do that is that you might want to calculate power if you wanted to replicate or extend this study. And so it's a bit of a pet peeve of mine that people all too often don't report the descriptive statistics associated with the figure. I suppose they're thinking that it's redundant or it's overlapping. Please don't think that. Just report them somewhere, either in a note of the figure or in a table or even in the supplementary materials. So how to calculate the confidence interval when all you've got are the how to calculate the standard deviation when you don't have the standard deviation and all you've got are the confidence intervals in the sample size. This is the formula. It's the square root of n multiplied by the difference between the upper CI and the lower CI divided by t, the relevant t value, times 2. Now this is the part that's a little more complicated to calculate than this part here. This is obviously very easy. You do have to eyeball this, to be honest. When you're looking at it, you're having to go, okay, what's the upper? This is maybe 3,750. If you take a ruler out, you can get pretty precise about what that estimate would be for the upper and lower bound. So you're stuck doing that as well if they don't report the actual precise values. Now this part here is the tougher part, and I'll show you how to do that in Excel. In fact, the whole thing can be done in Excel. So in this case here, I've actually I have raw data from which I can actually calculate the actual standard deviations. So I wanted to evaluate how precise this formula was, and it turns out it's actually quite precise. So the upper and lower bounds are all calculated here for the 4 groups, and the sample size was equal for all 4 groups, 19 in each group. And here's the actual standard deviation. Now here's the Excel function I created to estimate the standard deviation for each of these groups on the basis of the upper and lower confidence interval and the sample size. So it just starts off with square root of n, pretty easy, square root d2, times the difference between the upper and lower CI. So this is the easy stuff here. Then I have to divide by the t value times 2. And in this case here, the t value, because I want 95, or I should say the confidence intervals are from a 95% confidence interval perspective, I have to put 0.05 as my alpha level. If I only had 90% confidence intervals and I wanted the standard deviation, I'd have to put 0.10 here. And if you had 99% confidence intervals, you'd have to put 0.01 here. And this is the function to call the t value from the t distribution right here, t dot inverse dot 2t, and then the degrees of freedom here. And in this case here, that's n minus 1. So I've got $d, $2, because that's the sample size right here, and minus 1 times 2. And so that function gives me a very precise estimate of the standard deviation. Look how accurate that is. 1.224, actual 1.224. This one here is a little bit off to the 3rd decimal place, but not too bad. This one gets back on, and this one's back on track as well. So that is how you can calculate the standard deviation from a confidence interval.